Hello. Hello. Okay. So let's just start with the tutorial. So in this lecture, we will be talking about a few of the Python libraries using which you can code machine learning algorithms for your own dataset. Okay. So this lecture series is divided into two parts. Like one introductory lecture will be today, and tomorrow we will go with some advanced stuff using the stuff that we will learn today. Okay. So if you want to know about me, myself, Anil Sharma, I am pursuing PhD at IIT Delhi. My primary research interest is computer vision and reinforcement learning. If you want to check my work profile, you can go to this link. And if you want to like attend more lectures like this, so I would suggest you to join our Telegram channel, which is linked at this link, and also on Instagram. So we are only taking queries on Telegram and Instagram. Other platforms we may not be able to respond because of large number of queries on WhatsApp and like Twitter, for example. We started this initiative from Quora. You can check our Quora page on this URL. Okay, so so this lecture series will be more about some practical knowledge to machine learning. So we'll not be talking about much of the theoretical stuff for machine learning. For example, like we'll not be going into the deep mathematics. Rather, we will be like focusing on the real world application side. So that means it will be more practice oriented. It will help you learn how to code and use machine learning in Python for some specific data set. Okay, so and we will not be providing any evaluation of take home exercises that we will be giving in this lecture series, and a participation certificate will be given to all the participants after filling a feedback form. So what you should already know for this lecture series is strong programming skills in Python. In this lecture series, last week we took two lectures on introduction to Python, basic and advanced. So if you don't know about Python and programming in Python, I would suggest you to watch Introduction to Python series on our YouTube channel, thinklearn.ai. Okay, so tools that we will be using in this lecture is Google Colab. I also discussed it in the last week, like in detail. And alternatively, if you are familiar with Python and like coding on your own machine, you can use Jupyter Notebook or PyCharm, and that's also like highly convenient. So along with Google Colab, we will be using some Python libraries like Scikit-learn, which we will be using for machine learning algorithms and also for computing some evaluation and performance matrices. So we will be using NumPy and pandas for numerical operation and handling files. We will be using matplotlib for plotting and like doing some analysis using the evaluation matrices that we will be finding. So in the last week, we discussed all these libraries in detail. And if you haven't watched those videos, just go to our channel, YouTube channel, thinklearn.ai, and watch Introduction to Python videos. Okay, so before going to that, I think what I would suggest is subscribe to this channel and join our Telegram group where we will be posting about all these lectures, because we have stopped sending individual emails. Now we will only be sending reminders only on our Telegram channel and the Instagram group. Okay, so let's just proceed with this lecture. So first, let's just go with a little introduction. So just see this image. So now these days we are seeing the digitization of data. So that means earlier days we were using analog devices, and then like a few years back we were having electronic devices where we were getting the data in some digital form. But like these days, it's totally digital conversion of the data. So for example, if we are talking about an apple, we are not only talking about its weight, right? It's not only the digital form of the weight, but it's the digitization means that we are providing a hell lot of analysis of apple. So for example, what's the weight of this apple, what is the color of this apple, okay, how much nutrients this apple contains, how much protein does it contain. So for example, similarly for other products, like for example, if you want to say for some nuts, maybe almonds, you can provide some similar analysis, and you can say that digitization is giving a lot of information regarding products. So what I want to say in this slide is that digitization is changing our data, and it's not only about a particular value, it's all about the information of a particular object. Okay, so now how the world has changed is like how are we taking the competitive advantage from the different eras of automation. So for example, like in the 18th century we were highly relying on the manufacturing and mechanical devices. So if you see these things, right, so in that era the competitive advantage was coming from physical engineering and the labor capabilities. So then we moved to some other eras like production lines, electricity, where like we had automated machines. Okay, and those machines were doing our work. A few years back we were having automation, so we were having electronics, robots, IT manufacturing, like these kind of things were there. Okay, but these were like only the electronic form of devices, right? uh, these were not doing some analysis, they were not smart. Now in the digitization world, like this started like recently, where we are talking about sensors, data, connectivity. So for example, if we are talking about vehicles, we are not only talking about the mechanical device, that means the engine, we are also talking about the sensors, like it has GPRS, it has GPS, it has like in these days, in the coming days, it will also be coming with Wi-Fi direct. So that means the vehicles can communicate with each other. Okay, and apart from it, like there are other sensors that are coming, like cameras, ultrasonic sensors, radars. These are coming, and the vehicles are moving towards automotive industry. So that means on the right side of this image, we are taking the competitive advantage from the data and software, and we are making making a large amount of analysis just from the data. Okay, so the mechanical device like is common these days. Like, so we don't assume that like we will be doing something extra on it. But the competitive advantage, like for example, if there are two automotive manufacturers, their competitive advantage of those two will be coming from the digitization, from the data. Okay, so for example, if you compare Tesla with the other like automobile manufacturers, Tesla is highly advanced because it has taken a lot of advantage from the data of the vehicles. Okay. Okay, so let's just go to the machine learning now. So what is machine learning? It's a collection of methods and algorithms which provide better understanding of the data by learning like from data patterns. So for example, if you have data, it will like help us understand what that data is, and like it will provide better understanding of what are the trends in that data. Okay, so these methods enable machines to improve with experience. So for example, more the data that is coming, like more we are improving our method. Okay, so that means what machine learning is doing is we are giving the data to the machine learning algorithm, and it is giving us a better understanding of the data. Okay, so that means these algorithms can help us teach computers to understand the data. Okay, so for example, we can give image and video data to the computer to perform some computer vision tasks. So for example, object detection, or maybe some object recognition. So we can give the text data or speech data for natural language processing tasks. Okay, so these were the a few of the things. So now what kind of problems these machine learning algorithms can solve? So basically here we need to ask a particular question. Based on the type of the question, we have a different kind of algorithm. So for example, if the type of question is whether the input data contains a cat or a dog image. Okay, so if for this kind of question, we are having classification algorithms. Okay, so whether cat or dog, that means we are classifying the input data into different categories. So these are classification algorithms. How much or what value? So for example, how much will it rain tomorrow, right, based on the data that we have. So these kind of problems will be solved using the regression based methods. So is it weird? So for example, if we are seeing the data and are we saying there is something weird in this? So these are anomaly detection kind of approaches. Can we group that? So if we are having the data and if we can ask, can we group the data into multiple categories based on some criteria? Okay, so these algorithms are clustering algorithms. Okay, so if we are saying about decision making and there is no data, so for example, let's say if we have a robot. Okay, so if we want the robot to perform some task, so for example, like if we ask the robot to pick the plate and take it to the another room. Okay, so there is no data for it, so how the robot will make the uh, decisions. So these type of uh, like decisions are usually done by reinforcement learning based methods, and we will see a few of these in the in this lecture series. So these like most of these methods are classified into supervised and unsupervised category, which we will see in one of the future slide. Okay, so there are many applications of machine learning. So for example, in daily life we can use machine learning for smart home surveillance system. So for example, based on uh, based on your daily routine, like let's say this is a winter season, right, based on your wake up routine, the smart home can automatically switch on the geyser, switch off the geyser, right, these kind of things. Power usage analysis. So one of my friend, what it did is like it took the data of power usage of different homes, and then it like found a similarity pattern into the different homes, and then it says that like which homes are similar. Okay, and like what could be their future like next month electricity bill based on the history of the data that they had. Okay, route prediction, ad recommendation, for example, on Netflix, Amazon, Hotstar, and other online platforms. Face detection, face recognition. So for example, for surveillance, right, for example, at you in smart home, you can deploy a face recognition based system, and you can identify whether someone anonymous person is or like someone known person is coming to your home. So Google Translate is like good example of language translation models. Auto delivery and date prediction, robot chef, and there are many more other applications that are using machine learning in our daily lives. Okay, so why are we using machine learning? So for example, like the best common example is like we can't anticipate all possibilities. So for example, if we are asking a robot to take the plate, to lift the plate, right, so we can't so this is a continuous. So for example, uh, like if we ask a robot to pick the plate, right, there are motors in his hands. So like how much throttle should this motor supply so that like it will reach, that robot will reach, the hands of the robot will reach to the plate, right? So it's a continuous world, so we can't anticipate all the possibilities. And also there is a noise in the real world. So for example, if there is some air flowing, and right, the reading of the sensors change due to that. Based on the weather, the reading of the sensors change. So it's a highly noisy world. We can't anticipate all the possibilities. We may not know how to program a solution, that is cannot express our knowledge of pattern into a program. This is another common reason why we use machine learning based methods. So one of the important thing is like the real environment is too complex and it is dynamic. So for example, I gave an example of air flowing in certain environments, and there are too many parameters. Okay, example in weather forecasting, right? So if you see, right, like there is a traffic pattern, right? So which is creating some kind of some kind of pollution, like there is air flowing, there is some accident happening, right? So these kind of things that makes the real world highly dynamic. Okay, so limited prior knowledge, so we may not be having like the knowledge how to predict how to do the weather forecasting, right? So the machine learning system can do everything from just from the data. Okay, so this was an introduction of machine learning. So now in this lecture, we will be focusing a few of the important things. And then tomorrow we will be seeing common machine learning algorithms that we can use. So for example, the one of the first thing that you should know in machine learning is how to set up a data, right? So we will be seeing that first. Okay, first let's see, UCI machine learning repository is one of the best repository for machine learning datasets. So prior to deep learning, so that means prior to a few years, uh, we were using this UCI machine learning repository to like propose new machine learning algorithms or to learn machine learning concepts. Okay, so it hosts a large amount of free data sets, and you can use it for testing the efficacy of your machine learning algorithm. Let's just go to that URL and see what is this repository. So just go to this URL and just see, right? So it lists about a few of the news and like featured data set and the new data sets and most popular data sets. Okay, so these are the things. So just to see all the data sets, just go to this link, view all data sets. Okay, and then it will show you what all data sets are available. Okay, so there are 559 total data sets available. Okay, and these are the things. So let's just visualize one particular data set. So maybe breast cancer data set, let's just say. Okay, this is a breast cancer. This is the breast cancer data set. So it, okay, so this is the data set. Okay, it provides every details of the data set. So for example, it is a multivariate. Okay, we will see what is a multivariate. Multivariate means there are many features of in this data set. Number of instances means number of samples. Okay, and these are the things, right? And it also provides a few other information. Okay, you can download this data set from this data folder, and the description can also be downloaded from dataset description. Okay, so this is the UCI machine learning repository, and you can use these data sets for your work. Okay, so what is a data set first of all? Okay, so if you see this heart disease data set, okay, so I think I already told you, right, what are the dataset characteristics. Multivariate, that means there are many features in this. Number of instances means how many number of instances, that means how many samples are there. So for example, let's say if one sample is collected from one patient, so that means there were 303 patients. Okay, number of attributes means number of features. Okay, so that's why it's a multivariate. Okay, so are there any missing values? Yes, there are missing values, right? Okay, so it's for classification task. Okay, and attribute characteristics, there's some are categorical, some are integers, some are real values. Okay, so what are features and labels? Okay, so just see it. So for that hard data set, what we have done is we have listed all the attributes. So that means the attributes in that data set were the age of the patient, the sex of the patient, the CP, the blood pressure, cholesterol level, fasting blood sugar level, and the other these things. Okay, and the description provides like what values these attributes can take. So for example, age will be in years. So for example, 28 years or 30 years, like that kind of thing. Sex will be a categorical, one for male, zero for female, like so these kind of things. So that means the attributes could be categorical, like for example the gender of a person, of a patient, or could be integers. So for example, age or blood pressure. I'm not sure which of these could be real value, but there could be attributes which can take real values. Okay, so we need to see how we are taking the data set for the machine learning algorithm. So the original data set is provided as a whole. Okay, so now we need to see we need to, I think, we don't have to divide the training data on by ourselves these days, because most of the data sets are coming with their own split. But earlier there was no split. We were having only the original data, so we have to create our own split. So first of all, what we need to do is we need to separate out one part of the data set as a testing data set. Okay, and this is generally done using held out validation, or maybe you can randomly choose the testing samples. Okay, and then this training data set is divided into training and the validation data. So at the end we have three sets. One is a training set, validation set, and the third is testing set. In the training data, we are training our machine learning algorithm. Okay, so for example, if we are talking about weather forecasting, so what we will be doing is we will be learning a model to forecast weather for tomorrow using our training data, and then on validation data we will be tweaking some parameters for it. So for example, let's say if there is a parameter to say like how much will it rain tomorrow. Okay, so if it is dependent on some parameter, we are finding the best parameter using the validation data. Okay, so when we will select those parameters which will give good performance on this validation data. Okay, and then we will report the performance on the testing data. Right, so this is how a typical machine learning algorithm uses the data sets. Okay, so if we give an example for deep learning scenarios, so these days we are directly handling the data in raw form. So for example, images. So let's just say consider this in this data set where there are 10 categories like airplane, automobile, bird, cat, deer, and we have images corresponding to each category. So what we will be doing is we will be creating a testing and the training set out of it. Okay, and we will also, so basically like based so we need to make sure that there are equal number of sample of each category in the training and testing set, otherwise it will be an imbalanced set. Okay, so the labels and ground truth are both interchangeably used terms. Okay, so basically we create this split like using random selections. Okay, so and then we are creating two sets, training set, which are represented by X train and Y train. Y train is basically the label or the ground truth, and X train are the corresponding images. And similarly in the test set, we represent X test and Y test. So basically X is denoted as capital letter and Y is small letter. This is a common okay. First of all, iris data, and then what we will be doing is we will be uh, like loading these features from this iris data and the labels corresponding to it. Okay, so we will see how to do that. Okay, so let me just open this file. Okay, it's not going inside. Petal width, petal length, and petal width. Okay, so this is opened. Okay, so now let's just open it, and I just want to show you what kind of data we have in iris dataset. Okay, so for some reason it's taking too much time. It should not take. Okay, it's not responding. Okay. Okay, so this is the data set. is the name of the features, and the last column in these features is the category to which it belongs. Okay, and starting from the second row, the feature values, which are real values, and the class it belongs to. So there are three classes: iris setosa, iris versicolor, and iris virginica. Okay, so this is a kind of the data set that we have. Okay, so we will be loading only the feature values, like using the from the output of pandas read csv function, and then we are creating another label from the classes. Okay, so now there is a function train test bit in scikit-learn, which will automatically like split a training set and testing set for you. Okay, so if you use it, if you provide features and labels, it will automatically give x train x test, y train y test. Okay, so it will automatically split the testing set. Okay, so like in one of the coming slide, I will also show how to generate a k-fold cross validation, like but like in this slide I will be just talking about how to create a split using scikit-learn. Okay. Okay, so this was about the data set and a few of the common terminologies associated with it. Now let's just see what types of learning do we have in machine learning. Okay, so before going with that, let's just consider what pipeline a machine learning algorithm generally follows. Okay, so we will be talking about classification. Okay, so classification, what we do is we give the input data to a machine learning algorithm, and then we want what type of category the data belongs to. Okay, so for example, let's say we give an image as the input to the machine learning algorithm. Then what we need to do is we first need to do feature extraction. Okay, so that means we need to extract some features from the input data. So for example, in this image we can say that, okay, there are two circular patterns in it which are wheels. Okay, so there are windows in it, the bonnet is in some round shape. These kind of features can be there. The color of the car can also be one feature. Okay, after this feature extraction part, so we will be using a machine learning algorithm, for example svm or ada boost. So it will learn the pattern from the input features, and then based on some uh, some criteria, it will say whether the image contains a car or not a car. Okay, we will see how these algorithms work, but I just want to set up an idea to give you an idea to see, so that you can see how these machine learning algorithms work. Okay, we will discuss about these algorithms tomorrow. Okay, today we are doing deep learning, in which this feature extraction and the learning part are combined together in a neural network. Okay, and so that means we are giving the data directly and it is outputting the category. Okay, so the question arises, why are we talking about machine learning if deep learning can do all the tasks? Okay, so deep learning can do well on various tasks. Okay, but for some simple applications we are still using machine learning based algorithms. The traditional machine learning based algorithm, deep learning is also a part of machine learning. So but the traditional machine learning pipeline is also used these days for common applications. So for example, if you want to do some stock market prediction, you can use some regression based method. Okay, so deep learning is also used, but for deep learning we need a very large data set, and if this problem is highly simple, we don't have to use deep learning because it also requires a large amount of training time and a good hardware to train. Okay, so let's just see it in a detailed ML pipeline for classification. There are two steps: feature extraction and classification. The features are an individual measurable property or characteristics of the input data. Okay, so for example, if we are giving an input image of bike, it will do feature extraction. So for example, features could be that there are wheels, there is some bonnet, there is some backlight, there is headlight, like these kind of features could be there. Okay, classification is like process where we are categorizing the features into classes or categories. Okay, so for example, using this svm, let's say we are classifying into bike or not a bike. Okay, so this is an example of classification. Okay, so types of learning in ML are, so one is the supervised learning, where what we are saying is we are giving input data and associated annotations. So that means labels or ground truth information. Okay, so using that, so these annotations will say what is that data. So for example, this annotation says that okay, this data is of apples. Okay, so this brain kind of figure is our machine learning model. It will learn the pattern. Okay, so and at the later time, if we give a random image to this model, and we'll ask what category it belongs to, it will say that okay, it's an apple. Okay, it will predict it. So that means it is predicting based on the information that is learned from the annotated data that you have given. So here the supervised means the training is done using annotations. Okay, so the second approach is unsupervised learning, where we don't have annotations. That means the labels are not important, we just have the data. Okay, so that means we have the data. Okay, and we don't know what category it belongs to, but what we will be doing is, so we can extract the features from each data, and we can segregate it into different categories. So for example, the similar looking round like dark red objects can be combined together, which are apples. So the second one is, I guess, peach, and third one is banana. So these are categorized into different categories based on the similarity between each sample. Okay, so that means we have not given the annotation, but we are just categorizing it. Okay, the third type of learning is reinforcement learning. So for example, let's say if we are having an agent, or let's say a robot, and there is a fire to it. Okay, so we want the robot to learn what to do now. Okay, so it's a very weird example, but I could find this only. So what the agent can do is, let's say at the first step, let's say it goes directly to the fire. Okay, so it will get a negative reward. Oh, it's a painful, it's a heat, right? It will try to not repeat it. So the best step is first, so that means it will avoid it. So the right step is go to the tap, take the water in bucket and pull it to the fire. Okay, so that means based on the some random selections, it will learn which action needs to be taken at a particular time. Okay, so this is what reinforcement learning is doing. So here we need to note that we don't have the data, we don't have annotations. So in supervised learning, we had the data, we had the annotations. In unsupervised learning, we just had the data, no annotation. In reinforcement learning, we have nothing. Okay, so that means on trial and error, a particular agent will learn it, and by executing some actions, it will receive the reward, and based on the reward, it will learn. Okay, okay, so this was about some types of learning. Okay, so now the other thing that I want to discuss before going to machine learning algorithm is like what is feature extraction. Okay, as I have also talked earlier, so feature is an individual measurable property or characteristics of an input data. Okay, so for example, color, shape, size of an object. So for example, what we show earlier in terms of fruits. Okay, so each feature should capture a unique characteristic of the object. Okay, so for example, what you can do is you can also visualize a feature value. So for example, if we are saying the shape of uh, apple and peach, these are highly similar, right? So you may not get the best characteristics. So what you can do is maybe you can use a taste of each each object. So for example, taste of apple is different, taste of peach is different, so you can like use these as features, and visualization will tell you how far these values are. Okay, so for example, for this car, you can say that the color of the car, the shape, the bonnet shape, the vehicles, the wheels are some unique features. Okay, so the labels are the category the object belongs to. For example, this image belongs to car. Okay, so for example, the big container with 4 tires could be a car. Okay, an object is a sample with some set of features and associated labels. So for example, we are calling this particular object uh, as sample in machine learning. Okay, samples are represented by X, and the target value or the ground truth is represented by Y, as we have also seen in the dataset split case. Okay, so example like use like, so for example, if we are having image data, we can use image processing to extract useful features from the image of a car. Okay, so we will see tomorrow how we can do some feature extraction. uh, maybe not tomorrow, maybe in the next lecture series, where I will be talking about OpenCV and image processing. Then I will tell you how you can extract features from the image processing. Okay, in deep learning this process is automated. I have already like discussed this in one of the previous slide, that in deep learning we don't have to use it, but deep learning is highly like resource constraint, like has some constraints. So for example, it requires a good hardware, and these are typically slow. So we may have to do some manual feature extraction, so that if we want to run some real world stuff, then it will help us. The feature extraction will help us. Okay, so for example, let's just see this. This is the same example as we discussed, we've seen during datasets. What we have done is these are the features and these are the labels. Okay, so the features are the individual measurable properties. So for example, for the three classes, we have sepal length, sepal width, petal length, petal width. Okay, and the classes are three classes, so which is represented in the labels. Okay, so this is how we are representing the features and labels. Okay, so feature extraction is a very extensive topic. I have not included it into this slide because it may the individual feature extraction part can take 1 hour. So I have skipped it. Okay, maybe one of the future lecture series will talk about feature extraction. Okay, I think on OpenCV I will try to explain a lot of the features that we can extract from the images. Okay. Okay, so one important thing that you should know before going to the machine learning algorithm is the evaluation. Okay, so what does evaluation mean? Okay, so so just forget the topic. I have not. I will be talking about k-fold like after these two lines. So basically, different applications have different goals. Okay, so for example, in ad recommendation, the goal is to show the relevant ad to the user. Okay, in cancer detection, the goal is different. Okay, so you need to detect some disease from the data. Okay, so in evaluation metric is used to check if the machine learning model is achieving that goal. Okay, or how much accurately it is achieving that goal. Okay, so this is what evaluation metric will do. Okay, so we will be so one of the right approach of using the dataset is k-fold cross validation, which is a holdout method, where what we are doing is we are dividing the training data into k parts, and we hold a testing set in each iteration. Okay, so before estimating the evaluation metric, I think k-fold validation is important. So just see this. In the what we will be doing is we are dividing the data set into k parts. That means k folds we have to run. Just see the iteration one only. Okay, so in the first iteration, what we will be doing is we will be using fold one as testing set and the other folds as a training set. In the iteration two, we will be using fold two as a testing set and the others as a training set. So we'll repeat it like till k iterations, and then we will be using average accuracy of all the folds, and we'll see how much accurately our model is performing. Okay, so just to compute the k folds, this is the code that we will be using like from the Scikit-learn. We will be using model selection to find the k folds. Okay, so to generate k folds, what we can do is we can use dot k fold method from model selection. Okay, and then we can specify how many splits, how much split we want. Okay, do we need to do shuffle? Okay, so let's say we are using logistic regression. I will be talking about logistic regression tomorrow. Okay, and then so we can also compute the cross validation accuracy using this thing. Okay, so the accuracy I will be talking in the next slide. Okay, so but like I just wanted to tell you how to generate k folds in Scikit-learn. Okay, so what are evaluation metrics? So before that, just see what is a confusion matrix. So what we are doing is, let's say uh, these are the predicted labels at rows, and at columns we have actual labels. Actual labels means the ground truth. Okay, so let's say we have only two classes, class 0 and class 1. Class 0 is the negative class 1 is the positive class. Let's just say we have only two classes. Okay, so the confusion matrix says that the actual class 1, how many samples of actual class 1 are actually predicted as 1, and how many of actual class 1 are predicted as 0. Okay, so that means 1 going to 1 is a positive. That means positive sample class predicted as positive is a true positive. Okay, so let's just see the definition. True positives are samples belong to positive class and classified into the positive class. Similarly, for the false negatives, samples belong to positive class, but these are classified to negative class. These are false positives. Okay, I'm sorry for it. So these are false negatives. I'm highly sorry for it. These are false negatives. Okay, so these are positives. Okay, so now this is right. Okay, so false negative is the term uh, which means that something is classified as negative, but it was actually positive. Okay, so just say this, right? So the confusion matrix says that how much how many samples of a particular class are going to different classes. Okay, so I have shown only for one class. You can plot it for n classes as well. Okay, so these true positives, false positives are highly important in machine learning. We will be using these everywhere in all the in I think many of the like applications we use these metrics. Okay, so these are highly important. Confusion metrics may not be that important because it is used mostly for classification, but true positives are used for most of the applications. Okay, so the common evaluation metrics that we are using are accuracy, precision, and recall. Accuracy is just telling you about how many correct predictions are there out of a total number of samples. Precision will tell you how many of the positives are actually classified as positives. So that means, so for example, let's say if our algorithm says that there are 10 positives, okay, but how many of them are actually positives? That means, let's say if there are 5 positives are actually positives, and the algorithm says that 10 positives, so 5 out of 10. Okay, recall is the how many of the true positives are actually recalled. Okay, so this is that. Okay, so these terms may be confusing if you are seeing these for the first time, but these will become habitual when you start working with these. Okay, so these are many matrices, right? So what is there any one value that we can use as compared to one value? So for example, let's say if there are two algorithms, so for one has high precision, one has high recall, which one is good? Okay, so what we will do is we will be using F1 score, okay, which gives you the harmonic mean of precision and recall. Okay, so example code, how to do it, how to use it in Scikit-learn. So there is a method matrix in Scikit-learn. So let's say these are actual labels, that means the ground truth and the predictions which are algorithm predicted. So let's say these are these. So to compute the confusion matrix, matrix dot confusion matrix is a function, and the input is the ground truth and the predictions. It will give you the confusion matrix. Okay, so to compute the accuracy, there is a method matrix dot accuracy score. For precision, matrix dot precision score. Matrix dot recall score is for recall. Okay, so I did not talk it in the last lecture that if you write the string in this format, f followed by quotes, it will do the formatting. Okay, so accuracy score is, so it will fill in this value. Okay, this many percentages. Okay, so this is a shorthand notation of formatting strings. Okay, so there is another thing that you can do is a report classification report. Okay, so matrix dot classification report, let's just see what it gives. Okay, so this is the same code that I have written in the slides. Okay, so let's just run it. Like, let me just comment these out. Okay, and okay, so this is the first thing is confusion matrix. So that means the number of true positives in this is 3. Number of false negatives are 1. Okay, so this is the confusion matrix. So what does this classification report returns is, it will return you the precision, recall, F1 score, and these are the number of samples. Okay, accuracy, macro average, weighted average, accuracy. Okay, so I will be talking about I think I've already talked about what is accuracy is. This weighted average is not that important. Okay, so we will just focus on accuracy, precision, recall, and F1 score. Other things are not that common in machine learning. So what it says is zero class, one class. That means there are two classes. This is the precision of class zero, recall is this, and F1 score is this. Similarly for class one is this. Okay, this is what we are concluding. Okay, so this was about evaluation metric, and the output for the first three lines is this, and I have shown you the classification report in Colab. Okay, and this is how we will be using it. Other important terms that we use in machine learning are log loss, mean square error, R squared error, and ROC curve. Okay, so these are also other common terms which we highly use. I would suggest you to look into these because I'm not including these in the slides because like the only common matrices I have already discussed. Okay, but if for few other applications these are also used, which are highly common. You will see it anyway. Okay, ROC curve is very important for classification based algorithms to analyze those, and I will show you that. Okay, so what is a ROC curve? Okay, so first we need to compute the true positives and false positives by varying the model's confidence. Okay, so this is a new term. Now, what is a model's confidence? We will see it tomorrow. So model's confidence means that let's say if there is a parameter which tweaks this model's confidence, let's say parameter P. Okay, if I use the parameter P equals to 0, what is the true positive rate? What is the false positive rate? If I use P equals to 0.5, what is the true positive rate? What is the false positive rate? Similarly, if I keep on increasing it, what is the true positive rate and false positive rate? And what we will do is we will plot it into a curve. Okay, so the x-axis is the false positive rate, y-axis is the true positive rate, and if we get this kind of curve which is like at making 90-degree angle, it is the perfect classifier. That means it is giving you the perfect. That means 0% false positive rate and true positive rate is 100%. Okay, so this dotted dashed line is the random classifier which will anyway be there. Okay, so that means the random guess, the worst random guess, I guess. Okay, so the better the curve which will move to that this corner, the top left corner is the better algorithm. So why we use ROC curve? So first of all, it is used to compare the performance of multiple models. Okay, so the model which has the best, which is toward the right of the towards the top left corner is the best model. Okay, uh, it is also used to find the best operating point. So for example, if we have plotted these values at the different threshold points or the different parameter points, so we will see what is the point which is giving me the best score. So for example, there are different applications. For cancer classification, the true positive rate is highly important. That has to be highest. Okay, for maybe for some other application, let's say uh, for let's say um, for let's say uh, predicting the uh, predicting the color of an object. So for color of a fruit, right? So it's a worst, very bad example, but let's just say this is the example. Okay, for that true positive rate, false positive rate, high false positive rate, and should not be there. Okay, so what we will be doing is we will be setting a different operating point for different applications. So these curves are also important for that purpose. Okay, so if these curves are overlapping, so curve which has the highest area under the curve performs the best. Okay, so this is how ROC curves work. Okay, so this was about setting an example or like giving you an introduction of machine learning. Okay, where we have talked about a few of the common terms like data set, feature extraction, machine learning pipeline, and the evaluation metrics. Okay, tomorrow we will be using these in detail when we are talking about these three things. One is the what we'll be talking about supervised learning methods, First is a regression, where I will show you how to use linear regression, ridge regression, lasso, and logistic regression. And the second, I will show you how to use classification in scikit-learn. Okay, and then we will be also using unsupervised learning method. Basically, I will be talking about k-means clustering. Okay, and then one of the most important thing in machine learning is ensemble based method, where I will be talking about RDF, random decision forest. Okay, so these were the reason why we were using machine learning prior to deep learning era. Okay, so generally, if one particular machine learning algorithm does not perform well uh, on the on your training data, so what we do is we create multiple models, and we take ensemble of that. Okay, so we'll see how these work. Okay, so this is about today's lecture. Okay, if you have any question, uh, please send me on the chat, and I will try to respond. Okay, so this was the lecture series for Python for machine learning. Tomorrow I will be showing you some machine learning algorithms. Okay, and after this I will be talking about one more lecture series where I will show you how to use OpenCV on image data, where I will show you how to perform some operations, some how to extract features on images, and like, so for example, how to increase the brightness of the image, or like, so for example, if you are seeing TikTok kind of application, like how are they performing, how are they manipulating the user's image. Okay, so I will be showing those things. So I would suggest to join our Telegram and Instagram group. Okay, so to receive those notifications, because this registration, I'm not sure if we will be continuing sending emails to all the people. Okay, so the main thing is just join this Telegram group and the Instagram group, so that you can constantly receive the notifications about our next lecture series. And the feedback form will be shared tomorrow, and in the feedback form there will be a few questions from the lectures. So I would suggest to attend the lecture, so that you can receive the certificate. Okay, okay, so this was about today's lecture. So if you have any doubt, please feel free to ask it on the chat box. I will be waiting for another 2 minutes. If there are no doubts, I will leave from here. Okay, one person says, can you please send the PPT, sir? I will try, but I'm not sure if I can share the PPT, because like there is no communication method, and I don't want to spam everyone. So if there are any questions from the slide, please feel free to ask. If there are no questions, join our Telegram group. Okay, so that you can receive notifications about our future lecture series on OpenCV. I'm just sending the link of our Telegram group. Just join that. Okay, so I'm also sending the link of the Instagram. Okay, so I hope there are no queries. So I will be ending this live session in a minute. So if there are any queries, feel free to ask on Instagram or Telegram. We will try to respond. Okay, and stay tuned with the next lecture. Okay, so someone asked that if the classification problem has 3 groups, how can we make confusion matrix for that? So this method will automatically do this for you. Okay, so one thing, and another thing is like it is similar as 2 classes. I've just, for simplicity, I only showed for 2 classes. So for example, if you are computing for 3 classes, there will be third column and there will be a third row. Okay, uh, so this is how you will compute it. So that means you need to see how many samples of class 1 are going to class 1, are going to class 2, are going to class 3. How many samples of class 2 are going to class 1, class 2, class 3, and similarly for class 3. Okay, so this is what you do. If you don't want to write your own code, maybe you can use this method. Matrix.confusion matrix, it will automatically do it for you. Okay, any other question? I hope I have answered your question, Ashwin. Okay, so if there is any other question, please feel free to ask. Okay, so if there are any queries, please send your query on Telegram or Instagram. Okay, subscribe our YouTube channel. Okay, so that you can constantly receive like links for the future lecture series. Okay, so tomorrow we'll be talking about these topics: supervised learning, unsupervised learning, ensemble based methods, and we will also show how to like use machine learning methods on the real data. Okay, today was just a setup to give you some familiarity with some common machine learning stuff, like how to do the evaluation, how to use a dataset. Tomorrow we will directly use the algorithm, and after that we will be taking a lecture series on OpenCV. Okay, where you can perform so many operations on images. Okay, and you can create your own application, like Android application, to see how to apply hat on a head, like these kind of funny things. Okay, we will talk about that. Okay, so see you. Stay tuned for the next lecture, and bye bye.